Good morning, all. Today we are going to see about the topic search algorithm, which is come in artificial intelligence and data science. The subject code is 231 IT521 in which is comes in fifth semester. These are the outline of the today's presentation. So introduction. So what is meant by search algorithm? It is one of the most important area in artificial intelligence. So for search algorithms, we are using rational agents or problem solving agents in AI to use these search strategies algorithms to solve a specific problem and provide the best result. So these are the terminologies of search algorithm. First is search. Searching is a step-by-step process to solve a search problem in a given search space. What is meant by search space? Search space represents a set of possible solutions which a system may have. Then in search we have start state and goal state. So what is the start state? Which node we are starting now? That is the starting node, and end of the searching we have to find the goal state goal node. It is known as goal node. So in between the starting node to goal node, we have represent the search path as a tree, which is known as search tree. Then actions. Actions is described in description of the available actions of the agent. Then path cost. It is the function which assigns a numeric cost to each path. Then solution. Solution is known as the actions sequence. The solution is known as the to find the goal node. But what is the difference between optimal solution and solution? In optimal solution, we have to find the solution in lowest cost among all solutions. Then properties of search algorithm. There are four properties of algorithms: is there completeness, optimality, time complexity, and space complexity. Completeness is known as the to find the root from the root node to goal node. It is the completeness. The process is should be completed. It is known as the completeness. Then optimality. Uh, if the solution is found for an algorithm is guaranteed to be the best solution, which is known as lowest path cost among all other solutions. Then time complexity. Time complexity is the measure of time for an algorithm to complete its task. Space complexity. It is the maximum storage space required at any point during the search as the complexity of the problem. Then uninformed search. We have two types of search algorithm. One is uninformed one, or which is called as blind search also. Another one is informed search. In uninformed or blind search, we have six algorithm: breadth first search, uniform cost search, depth first search, depth limited search, iterative deepening depth first search, and bidirectional search. In informed search, we have two algorithms: best first search or greedy search, and A star search. First, we are going to see about uninformed search algorithm. So, uninformed search algorithm is known as the algorithm which is don't aware of the search space. It is called as uninformed search or blind search. So, in uninformed search, we are having six types of algorithms. So, first one is breadth first search. So, a breadth first search algorithm, we have to find the goal state from root node in breadth wise. So it is called as breadth first search. It is also implemented using FIFO quick queue data structures. The advantages of breadth first search will be it will be provide a solution if any solution exists. If there are more than one solution for a given problem, then breadth first search will provide the minimum solution which require the least number of steps. Disadvantages: it requires lot of memory since each level of the tree must be saved into the memory to expand the next level. It needs lots of time to find the solution. For example, There are a tree will be given. In breadth first search, we have a example. From this, we have S as a starting node or root node, then K as the goal node. So in this, we have to search level from level 1, then come to the level 2, from left side to right side it will search. So A to B, again it will not find the goal node, then it comes level 2, then C D G H, then it will come next level, then E F, then it search I, at last it come level 4. So there it will find the goal node. So the time complexity of the breadth first search is T of B equal to 1 plus B square plus B cube plus up to B power D equal to order of B power D. Then space complexity, it is known as order of B power D. Completeness, it is a complete one because it find the goal node. Okay. Then optimality. Optimality, it is a optimal if path cost is a non-decreasing function of the depth of the node. Then depth first search. In depth first search, it will find the goal node from in depth wise. From root node to depth wise, it will find the solution. Advantages of depth first search is it require very less memory. It only needs to store a stack of the nodes on the path from root node to the current node. It takes less time to reach the goal compared to breadth first search. Disadvantages, there is a possibility that many states keep reoccurring and there is no guarantee to find the solution. It goes deep, so deep while searching, so sometimes it go to the infinite loop. This is the example for the depth first search. So this is the example for depth first search. In this we have 4 levels. In level 1, level 0, we have SSS starting node. Then it search the goal node in depth wise. So then in left to or left, from left it search the in depth wise. So S to A, then A to B, again A to D, then D to E, and E to C, then C to G. If it find the goal node, or else it comes to from G to H, then I, then K, then it go to J. So likewise it search, but in between we have to find the goal node, so it stopped the search. The space complexity of depth first search is order of BM, and the optimality of depth first search is it is a non-optimal because while searching in depth wise, we have, if we are not finding the goal node na, it will go infinite, so it is not an optimal one. Then completeness, it is a complete within finite state space. Then time complexity is order of n power m is known as the time complexity of depth first search. Next one is depth limited search algorithm. It is similar to depth first search, but it is in this we have to given the limit of the depth. If two condition, it is based on two condition. First one is standard failure value. It indicates that problem does not have any solution. Cutoff failure value, it defines no solution for the problem within a given depth limit. The advantages of depth limited search algorithm is it is in memory efficient because before itself we given the limit of the limit for the search algorithm. Then disadvantages. Depth limited search also has an advantages of incompleteness. It may not be optimal if the problem has more than one solution. In this example, we have four levels, but we given the limited up to level 2, that is 3 levels only. So from S is the starting node, from S it search A, then it search C, then it won't search E because we are giving the limit up to level 2. So then it go breadthwise, then D, again B, then I. At last, it find the J. It is this goal node of the particular problem. And this completeness is a depth limiter search algorithm. It is a complete solution. But because the if the solution is above the depth limit, now it is a completeness. Then time complexity is known as order of B power L. Says space complexity is known as order of B into L. Then optimal. It can be viewed as a special case of depth first search, and it is also not optimal because we can't able to find the solution. Within the depth limit, it is not, there is a goal node, we cannot find the solution. Then uniform cost search algorithm. It is a traveling weighted graph algorithm. Between one node to another node, we have a from one node to another node, we have a cost. So using based on the cost wise, we choose the next node. So the advantages of uniform cost search algorithm, it is an optimal because at every state the path will be the least cost is chosen. So it is a cost wise, it will be less only. Then disadvantages, it does not care about the number of steps involved in the searching. It only concentrate on the path cost. So sometimes it have a memory, it occupy the more memory. So the completeness is uniform cost search is a complete search as if there is a solution. Then time complexity, C into epsilon plus 1. Then space complexity is order of B power 1 plus C into divided by epsilon. Optimality. Uniform cost search is always an optimal as it only select a path with the lowest path cost. In this example, we have SSS starting node. Then we have A and B node. From A, it has one path cost. To B, it has 4 path costs. So it choose 1. Then after A, it goes to C and D. For C, it has 3 as a pass cost. Then for D, it has 2 as the path cost. So it choose D. Then D, we have a goal node as path cost 3. So it choose the goal node. Okay. Next algorithm is iterative deepening depth first search. It is the combination of depth first search and breadth first search. But it up to we find the goal node, we have to increase the limit of the search of the algorithm. So first we have to search from level 0, then level 1, level 2, up to like this. We have to increase the iteration up to find the goal node. The advantages is known as it combines the benefits of BFS and DFS search algorithm in terms of fast search and memory efficiency. Disadvantages. The main drawback of iterative deepening search, it repeats all the work of the previous phase. So if it searches level 0 or level 1, and then we have given the limit up to level 2, but it is searching from the starting itself. So we have spend the more memory to implement this algorithm. In this example, we have we taken first iteration at level 0. So in this we have an A only. So it is not the goal node. Then we increase, we go to the second iteration. In this A, B, C there is. Then again it search A, B, C. Then next we given the level up to level 2. Then with the search starting from A, it again search B and C. Then it again search D, E, F, and then G. So here we find the goal node. Or else we go to the next level. In next level also it search from A, B, C, D, E, F, G, then H, I, K. Likewise it search. So it is a memory efficient. Then in fourth iteration we find the in third iteration itself, we find the goal node. The completeness, it is this algorithm is complete. The branching factor is finite. Then time complexity order of b power d, space complexity order of b into d. Optimality. Yeah, this algorithm is an optimal if path cost is non-decreasing function of the depth of the cost. Then bidirectional search algorithm. In this algorithm, we have two simulation searches. One from the root node to the goal node, again from the goal node to the root node. So at the one point, each simulations will meet one point. So we have to find the path from root node to goal node. But in this, one drawback is that for this to implement this algorithm, we have to find both. We have to know before root node and goal node. Even if we always known about the root node, but we have to in some situation we have not known the goal node. So in this problem, we cannot implement the bidirectional search algorithm. If a problem has to known root node as well as goal node, in this situation only we have to use the bidirectional search algorithm. So the advantages is it is fast, it requires less memory. The advantages, disadvantages, it implements the bidirectional searches, it is somewhat difficult. Then it should know the goal state in advance. This is the main drawback of this algorithm. In this example, we have root node as 1, then goal node as 16. So it from in one simulation from root node to goal node it will search. Then another simulation from goal node to root node it will search. So at last the intersection they both simulations is meet in node 9. This is the intersection node of the so we will find the path from root node to goal node 1, 4, 8, 9, 10, 12 and 16. So this is the path from root node to goal node. And the completeness, it is the completed one. Then time complexity order of BD, space complexity are also order of BD. Then optimality, it is an optimal one. Next, we are going to see about informed search algorithms. Still, we are seeing about uninformed research algorithms. There are 6 types of uninformed research algorithms. Then now we are going to see about the informed research algorithm. So it contains the array of knowledge such as how far we are from the goal, the path cost, how to reach the goal node. These are the details are known. So it is known as informed research algorithm. This knowledge, the above knowledge, is help the agent to explore less to the search space and find more efficiently to the goal node. The informed search algorithm is more useful for large space search space. Informed search algorithm uses the idea of heuristic here. It is also called as heuristic search algorithm. So what is the heuristic function? The heuristic is a function which is used in informed research, and it finds the most promising path. It takes the current state of the agent as its input and proceeds the estimated of how close agent is from the goal. The heuristic, each and every node has an heuristic value. What it is mean no? The particular node, how far it is from the goal node. So this is the heuristic value, not the path value. So each and every node has the heuristic value. So it is denoted as h of n. And it calculates the cost of the optimal path between the pair of the state. The value of heuristic function is always a positive one. First, we are going to see about it. In informed research, we have 2 algorithms, best first search algorithm and A-star search algorithm. First, we are going to see about the best first search algorithm. In best first search, it is also called as greedy search. So in this, place the starting node in the open list. Then first, the open list is empty. Then stop and return the failure. Then remove the node n. Then we choose the next node using the heuristic function. Then It is in closed node. If we find the less heuristic function node, na, it will be moved to the closed node. Other nodes are kept in the open node. At last, we find the path of the solution. Then advantages. The best first search can switch between better search and depth first search by gaining the advantages of both algorithm. This algorithm is more efficient than BFS and DFS. The disadvantages. It is an unguided open first search in the worst case scenario. It can get stuck in loop as depth first search. This algorithm is not an optimal one. So in this example, we have a problem. So S, A, B, C, D, E, F, G, H, I, and G. So in the tree itself, they are giving the path cost of the travel from the node. Then again we are having one heuristic table. So this is denoted as the particular node, how far it is from the goal node. So based on the particular space between the node and goal node, we are giving the heuristic function. Heuristic function is not same as the path cost. Path cost is known as the cost between the two nodes, but heuristic function is denoted as the value which is given like the current state of the particular node, how far it is from the goal node. So based on this, we are giving the heuristic value. So in this example, first of all, we are have starting from S. Then in open, we are having two options, A and B. Then we are choosing B. Because the heuristic value of the B is lesser than A. So we are having heuristic value as 4, B as 4, A as 12. So we are choosing B. So we are put the B in closed space S comma B. And then next iteration in from B we have E, F and EF. So we are put in the open list. Then we are find the heuristic value of E and F. E has 8, F has 2. So we are choose the F, which is so we are put the F in open list. Again from F, we are having I and G. So for I, we have the heuristic value 9. For G, we have 0. So because G is the goal node, so from goal node to goal node itself, we have the heuristic value as 0. So we find the G. Then we given the G as closed path. From closed is the open is the not the solution of the particular problem. Closed is the solution of the particular problem. In closed we have S, B, F and G. So this is the root of the solution path from root node to goal node. So the time complexity of best first search is order of B power m. The space complexity is order of B power n. It is not incomplete. Then it is also incomplete because in particular given search we cannot find the solution. It is not completed on. If then optimality. If it is not, if we have a chance to, it is not complete now. So, but how we can have an optimal one? It is not an optimal. Next one is A star search. In this algorithm, we have to bother about both heuristic function and the g of n, that is path of the function. So in this, we have to add both numbers and then find the solution of the problem. So advantages of A star search. It is the best algorithm than other search algorithm. Compared to other search algorithm, it is the best search algorithm. A star search algorithm is optimal and complete. This algorithm can solve very complex problem also. Then disadvantages. It does not always produce the shortest path, as it mostly based on heuristic and approximation. A star search algorithm has some complexity issues. The main drawback of A star is a memory requirement, as it keeps all generated nodes in the memory. So it is not practical for various large scale problems. So in this also we are having open and closed list. Then we have to find the root from root node to goal node. We have to find the part which is kept in the closed node. So in this we have S as a starting node, then G as a goal node. So in this we also have a path cost as well as heuristic function. The path cost is known as G of n. The heuristic function is known as H of n. So first we have yes, and then we choose the less path cost. From yes we have A and G goal node compared to A and G. We choose them A because the path cost is lesser, and also we are so we choose A. Then from A to B or C, we are choosing C. Then C to 3 or 4, we are choosing G. Because we have to, how we are choosing now, we have to add the both values. From yes, we have A. So what is the path cost of A? 1. What is the heuristic function of A? 3. So 1 plus 3 equal to 4. So here we have to add 4. Then for G, we have a path cost 10 and our heuristic function is 0. So which is it is the values the value is 10. So compared to 4 and 10, we choose 4. Again, A to B or A to C. So here A to B we have 2 plus B equal to 4. So we have 6 value here. Then here 1, C is 2. So we have 3 values here. So we choose 3. Then D, G. In D we have 3 plus 6. So 9 value is here. Then for G, we have 4 plus 0. So we have 4 values. So we choose on this value. So the the root path is, solution path is S, A, C, and G. The properties of A star search algorithm. The completeness. It is the completeness because the branching vector is finite, cost us at very action is fixed. Then optimality. It will be optimality based on the below two conditions. First one is admissible. It is the first condition required for optimality, that is heuristic H of n should be an admissible heuristic for A star search. It is an optimistic in nature. Then consistency. In consistency, we have only A star graph search. If the heuristic function is admissible, then A star tree search will always find the least cost path. And time complexity is order of B cap D. Then space complexity order of B cap D. So in this presentation, we have seen about the what is meant by search algorithm, then properties of search algorithm, the terminologies of the search algorithm, and the types of search algorithm. We have two types, uninformed search algorithm and search algorithm. In uninformed search, we have seen about the 6 algorithm. In informed search, we have seen about the 2 algorithm. So I hope you are understand the concept. Next, we are meeting another topic. Thank you.